Today on Daily Tech Hack Global, 3 signals define the AI and security week. First, Zoom patched a serious meeting vulnerability after researchers said public AI models helped uncover it with fewer than 20 prompts. Second, OpenAI is putting cyber-specific frontier models into a governed program for authorized defenders. Third, NVIDIA is pushing both agentic AI models and the data center power architecture needed to run them. The takeaway is simple: AI is no longer just a feature. It is changing how vulnerabilities are found, how defenders work, how developers build, and how infrastructure gets designed. Story 1 is the most practical for everyday users and businesses. The Zoom vulnerability story, reported by The Verge from researcher and Wired coverage. The confirmed feed summary says Zoom patched a major security vulnerability that could allow an attacker to hijack a device during a meeting. Researchers at a security said they uncovered the flaw using fewer than 20 prompts on publicly available AI models, and the exploit involved Zoom's annotation feature. We are not going to walk through exploitation details. The defensive lesson is that AI-assisted research lowers the time cost of finding unusual interactions in complex software. That helps defenders, but it also compresses patch windows. If your organization depends on meeting software, browser extensions, screen sharing, or remote support tools, treat automatic updates and rapid patch verification as basic security hygiene, not optional IT housekeeping. There is a second lesson in that same story: AI does not have to be magical to be impactful. Fewer than 20 prompts is not a supercomputer project. It suggests that public models can help a skilled researcher ask better questions, map a feature surface, and reason about edge cases. For builders, this means secure design reviews should assume that attackers and defenders both have better assistance. Threat models need to include odd feature combinations, file parsing, collaboration tools, and permissions that cross from a meeting into a local device. Story 2, OpenAI's Daybreak expansion. OpenAI's own RSS feed says it introduced GPT 5.6 Cyber, a cybersecurity-specific model available through Daybreak Red for authorized vulnerability research, exploit validation, and security testing. A related OpenAI post says approved Daybreak partners can use frontier cyber models to deliver authorized, governed cybersecurity services to customers. The confirmed fact here is not simply that a new model exists. It is that access is being framed around authorization, partners, and governed use. That matters because cyber models are dual use. The same capability that validates a bug for a defender could be misused outside a legal scope. For security teams, the opportunity is faster triage, better reproduction of issues, and more consistent validation of defenses. The uncertainty is operational. Customers will still need policy, logging, human review, and boundaries around what a model is allowed to test. The right question for buyers is not, can this model hack? The right question is, how is authorization verified, how are outputs reviewed, what telemetry is retained, and how does the service prevent crossing from defensive validation into unauthorized activity? Story 3, NVIDIA's agentic AI stack. NVIDIA says Nemotron 3.5 Lightning and NeMo Switchyard are aimed at faster, smarter, more efficient agentic AI workloads. The company frames the shift as moving from chatbots to autonomous agents, with open models serving demand for control over where AI runs, how it is deployed, and how it evolves. For developers and CIOs, this is the agent conversation becoming practical. Long-running agents need efficiency, routing, observability, and deployment control. A demo can run as a prompt chain. A production agent needs cost limits, identity, permissions, tool safety, and rollback. That connects directly to today's security theme. Once an agent can call tools, fetch data, write tickets, change code, or query dashboards, it becomes part of the trust boundary. The model choice matters, but so do boring controls, least privilege tokens, isolated workspaces, audit logs, allow listed tools, and clear escalation paths when an agent is uncertain. Story 4 is NVIDIA's AI Factory Power Architecture post. NVIDIA argues that scaling AI compute requires more than wattage. The bottleneck is increasingly how power gets from the grid to GPUs, especially as rack density rises and AI factories need efficient, scalable distribution. For the broader market, this is why AI capacity is not just about buying chips. Data center power, cooling, grid interconnects, and electrical architecture can decide how quickly new model capacity comes online. For businesses, the implication is budgeting realism. If your roadmap assumes unlimited AI inference, the physical layer may become a constraint. Expect more attention on model efficiency, workload scheduling, regional capacity, and hybrid deployment. Efficient agentic models and better power architecture are two sides of the same pressure, more AI demand meeting finite infrastructure. Story 5, GitHub's Copilot SDK for Java. GitHub says enterprise Java developers can drive GitHub Copilot from idiomatic Java code with annotations, virtual threads, and related tooling. The direction is clear: AI coding assistance is moving from a chat window into the software development stack. That can improve productivity, but it changes review discipline. Teams should define where AI-generated changes are allowed, require tests and human review, and avoid one giant unreviewable pull request. AI in development is strongest when it reduces repetitive work while preserving ownership. Story 6, Ars Technica's Passkey coverage. Ars reports that a new Passkey attack reveals differences in how Passkey apps treat Windows compared with other operating systems, while also framing the issue as mostly not a reason to abandon passkeys. The defensive takeaway is balanced. Passkeys remain a major improvement over passwords and phishing-prone one-time codes, but platform behavior matters. Enterprises should document supported authenticators, test recovery flows, and avoid assuming every passkey implementation has identical risk. One quick operational security note from TechCrunch: Delta is investigating after someone reportedly set up a fake Wi-Fi network mid-flight, and the legitimate aircraft Wi-Fi was switched off for around 30 minutes. That story is not primarily AI, but it is a useful reminder for travelers: verify network names, prefer cellular when possible, use a trusted VPN for sensitive work, and never install certificates or updates because a captive portal asks you to. Here is the wrap-up. The strongest pattern today is compressed trust. AI helps find bugs faster, cyber models need governed access, agents need tool boundaries, AI data centers need new physical designs, and developers need review discipline as coding assistants move deeper into workflows. Confirmed facts and source links are in the description. If you manage systems, your action list is short: patch collaboration tools, define AI agent permissions, ask vendors about cyber model governance, plan for AI infrastructure limits, and keep humans accountable for security decisions.